Triangle coordinate proofs. Coordinate proofs place figures on the Cartesian plane to make use of the coordinates of key features of the figure, combined with formula like distance formula, midpoint formula, and slope formula to prove something. The use of the coordinates is simply an alternative approach in conducting the proof. We'll provide a few examples and then have you do some proofs. Given the points A, B, C, and Q, where A is at 0, 4, B is at 3, 0, C is at -3, 0, and Q is at the origin 0, 0, they are the vertices of triangle ABC and triangle AQB. Prove that line segment QA bisects angle CAB. So let's sketch the triangles on some graph paper and then discuss a strategy to accomplish the proof. Does this sketch look like the one you did? If not, take a moment to see if this is correct. Looking at this, our strategy becomes clear. If we can prove that triangle AQC, so this one here, is congruent to triangle AQB, this triangle over here, then angle CAQ, so this angle right here, would be congruent to angle BAQ, so this angle here, which would allow us to conclude that AQ bisects angle CAB. Let's get to work. From the graph, we see that CQ equals BQ, and they're both equal to 3, and AQ equals 4. You should be able to see that these are two right triangles with identical length sides, so they must be congruent. Let's work through the proof as good practice. Alright, so here's our proof. We see that these sides here are congruent to each other because they both have lengths of 3. We see that this shared side between the two triangles is congruent to itself because of the reflexive property of congruence. We also know that these two segments here are perpendicular to one another because the x and y axes are perpendicular, and perpendicular lines form adjacent angles, so we know that these two angles here are congruent to each other. Therefore, by side angle side congruence, we know these two triangles are congruent. Therefore, angle CAQ here is congruent to angle BAQ here because corresponding parts of congruent triangles are congruent. Therefore, QA bisects angle CAB because that's the definition of an angle bisector. Given 3 points A, B, and C where A is at 4, -1, B is at 5, 6, and C is at 1, 3, prove that triangle ABC is an isosceles right triangle. Make a sketch first and think of a strategy for this proof. To start, let's show that the slopes of BC and AC are negative or opposite reciprocals. Then use the Pythagorean theorem to determine if the lengths of BC and AC are equal. Write a paragraph proof. Alright, so given these 3 points, we determined the slope of BC is 6 minus 3 over 5 minus 1, which is 3 over 4. And the slope of AC is 3 minus -1 over 1 minus 4, which is -4 over 3. The slopes are negative reciprocals, so that means that AC is perpendicular to BC, which makes triangle ABC a right triangle. By the Pythagorean theorem, we see that both of those legs have a length of 5, which means that those segments are congruent. Thus, triangle ABC is an isosceles right triangle. Given A, B, and C, where A is 1, 1, B is at 4, 4, and C is at 6, 2, prove that triangle ABC is a right triangle. Make a sketch first and think of a strategy for this proof. Come up with a plan that would allow you to prove that triangle ABC is a right triangle. Write a paragraph proof. Alright, so given these 3 points, the slope of AB is 4 minus 1 over 4 minus 1, which is 1, and the slope of BC is 2 minus 4 over 6 minus 4, so that is -1. The product of the slopes is -1, so that means that these two segments here are perpendicular, which makes triangle ABC a right triangle.